All right. Hello, everyone. My name is Pierre Chastenay. I'm a professor of science education and astronomy education at Université du Québec à Montréal. And today I'm going to talk to you about a new project that I'm working on with my colleagues Patrice Potvin at Université du Québec à Montréal and Lucia Mason at Padua University in Italy. It's about using a refutation video to teach the seasons. Now, why teach the seasons? Well, first and foremost, that's because the seasons is in the curriculum of most countries in the world, mostly at the end of elementary school and early high school. But it is also taught in most Astro 101 university courses. That's especially the case in North America. Seasons is also a basic astronomy concept that has a huge effect on people's lives. And so we would like to think that people are able to understand and explain why we have seasons, especially in the temperate regions of the globe. But we also know that season is one of the most difficult concepts in astronomy to teach and learn in the classroom. And that's mainly because there are two major misconceptions that are very deeply entrenched in people's way of explaining the seasons. And those misconceptions are what I call the distance plus orbit and the distance plus tilt. These two misconceptions are extremely robust. The distance plus orbit misconception you probably know already because most people who are asked to explain the seasons will tell you that seasons are caused by the variation of the distance between the Earth and Sun. When the Earth is closer to the Sun, it's summer. When it's farther away, it's winter. That does not explain, of course, the fact that the seasons are reversed between the hemispheres, but that's another story. Another misconceptions that may be less well known, but very, very pregnant as well, very important, is what I call the distance plus tilt. This is based mostly on the illustrations that you'll find in textbooks and on the internet, where the sun and the earth are about the same size. They're very close to one another, and the earth is tilted on its axis. And because of that, it's clear from the illustration that the northern hemisphere in this case is closer to the sun than the southern hemisphere. And so the north of the planet receives more heat from the sun, whereas the south part of the planet receives less heat. Hence the seasons, of course. And that has the advantage of explaining as well why the seasons are reversed from one hemisphere to the other. So those two misconceptions, again, are extremely robust. They're hard to move. And so we have to find ways to help people overcome these misconceptions and embrace the scientific explanation for the seasons. One way to do that, and it's a way of teaching that has been used for decades now, is the use of refutation. So it can be refutation texts, they can be refutation images. What I'm proposing here is refutation video. I'm going to talk about that in a few minutes. So basically, a refutation text in that case is a text with a very strict structure. It begins with the explicitation of a very common misconception. In this case, that the camel stores water in its hump. It's followed by your refutation cue, whereas we say this is not true or this is false or don't believe that sort of thing. And it's followed by an explanation based on the scientific understanding of the phenomenon. In this case, the hump of a camel does not contain water. It contains fat that can be transformed in water as need be. So these refutation texts, again, have been around in science education for decades. And so people have begun to ask, because the fact that refutation texts are more effective mostly than standard text for conceptual change, if we add images to these refutation texts, would they be even more superior in terms of learning or inducing learning in learners? And the question I ask is, what about a refutation video, which would be especially useful in terms of astronomy teaching, where changing point of view on an astronomical system is so important. There has been previous research done by the likes of Broughton, Sinatra, and Reynolds in 2010. These guys basically used a refutation text about the season and an expository text about the seasons. Both texts had the same length. The expository text is something that you would find in a common textbook. And both texts were accompanied by a classic image of the four Earth around the sun on a very elliptical looking orbit. And so what they did basically is ask students a series of questions about the seasons before to reveal their misconceptions. They asked students to read either the expository or the refutation text, and they asked the same questions afterwards. What they found is that the students who read the refutation text had fewer misconceptions right after reading the refutation text, but after 14 days, the delayed post-test showed that the misconceptions had come back. So very mitigated results, if I can say so. Lucia Mason and her colleagues in 2017 went a step further. So they used the same expository and refutation text as the study by Broughton and colleagues, but they added expository images and refutation images as well. And so they checked for the combination of refutation and expository text and images. So they basically had 4 treatments, and they compared the treatments with 18 years old students. And unfortunately, they didn't find any advantage of the refutation text and the refutation images combined over the 3 other treatments. So again, very unfortunate results. And I think that is at least my explanation for these results. I think that the problem lies in the use of illustrations in astronomy, 2D illustrations in astronomy, like the one you see on the screen right now. Basically, these images, because they're two-dimensional, they don't show the depth of space. We are missing the third dimension, so to speak. They are not to scale. They are static or pseudodynamic. When I say pseudodynamic, I mean, for instance, having several Earths around the sun on the Earth's orbit. They are implicitly in perspective, but it is never said. They are implicitly in perspective, sorry, but it is never said explicitly that what you see is a circular orbit, but in perspective. And so, because of all these reasons, it becomes extremely difficult for novices to interpret correctly. And in fact, several researchers are convinced that these images are the source of most misconceptions in astronomy. So our reflection is that maybe we could overcome these limitations by using a refutation video instead of a refutation image or static images. And that's what we came up with. So what you see right now is just an excerpt from a 6.5-minute long refutation video. The advantage of this video is that it was built in part using planetarium visualization software. So we were able to travel in space, move around the Earth and Sun system. We were able as well to land on the Earth and look at the Sun's trajectory from the geocentric perspective in the northern and the southern hemisphere. And so you see the result here. And our hypothesis is that by showing different points of view on the Earth-Sun system, the geocentric point of view and the allocentric point of view, which is the view from space, we should be able to help learners better understand the mechanism of seasons. And of course, in the refutation video, we also make sure that we try to deconstruct the 2 main misconceptions that I've presented earlier in this talk. Of course, we have the refutation video, but we also made an expository video which used the same images, but with a different text, of course, which does not necessarily dwells on the presence of misconceptions. And we also used the narration or the text supporting both videos to create a refutation text and an expository text with static images. What we did when we had finished the refutation videos, just test it, just to see, test the temperature of the water, if I can say so. And so we did a small pilot study with 10 people, mostly our science education graduate students and a few of my colleagues at Université du Québec à Montréal. So basically, I asked them a few questions about the seasons, then I showed them the video, the refutation video, and then I asked the same questions again. I didn't do any statistics because n equals 10 is really not that much. But you can tell by comparing the tables, the top and the bottom tables, that before seeing the refutation video, people had a lot of misconceptions, mostly the distance plus tilt misconception to explain seasons. And in the post-test, you see that this misconceptions has almost completely disappeared. And so there is clearly an effect of the refutation video on these people, at least. And so I think it's a good sign, and it convinces us to move forward. So the next step, and that's where we're at right now, we are trying to compare the refutation video about the seasons with an expository video, a refutation text, and an expository text. Both texts are accompanied with static images. And this is an experiment that is ongoing right now in French only, using the Gorilla Experiment Builder. And basically what we are trying to do is compare the 4 treatments: expository text, expository video, refutation text, refutation video. And we hope that with the data that we are collecting, we will be able to show a statistically significant advantage of refutation video over the 3 other treatments. Our goal is also to produce an English and Italian versions of the 4 treatments that's upcoming. And of course, I'm presenting this to you today because I hope that some of you will be interested in participating and maybe adapt the experiment in your own language. So you have my email address right there on the slide. It is also on my thank you slide. And so I really hope that you'll be interested and that we can work together in the future. So thank you very much for your attention, and I'll be happy if I'm there live to answer some of your questions. Thank you very much.